inverse functions. This is the whole reason why we do, one of the reasons why we do composition of functions is inverse functions. So what we did yesterday, we're going to use today. So it says, what is it? That's a good question. Well, if I take a look at how a function operates, we have the domain and we have the range. A function takes x values in the domain to y values in the range. So that's what it does. So it picks this up, x is up in the domain, takes it to y's in the range. We say x goes to y, x goes to y, x goes to y. Put in x, get out y. Put in x, get out y. That's your function. Now, what we want and what the inverse function does is that it will pick up y values in the range the inverse of f, y values in the range, and return them to x values in the domain. Now, the reverse process is necessary because we actually use it for equation solving. So when we look at the inverse function is really the inverse function is the undo button for the regular function. It's what undoes what was done. It says if x goes to y, the inverse brings y back to x, I end up where I started out. It's like the round trip ticket if you're going to go somewhere. If I'm going to go visit my family on the East Coast in Washington, D.C., I would fly from here to Washington, and I'd have a round trip ticket which would bring me back to here. That's what the inverse function is. It's the return flight. It's the return flight. So we have seen that before. It's the undo. We use it for equation solving. So the square root of x and x squared are inverses. Because how do I undo a square root? If I were solving an equation that involves square root, what would I do? Square both sides. So that says I get rid of a square root by squaring. And how do I get rid of a square? You square root it. It's the undo button. It allows us to solve equations. It undoes what was done. Now the notation for the inverse function is kind of funky. If I look at notation, it's f minus 1 of x. Kind of spread it out like that so we can mark things up. This says f inverse, and this says of x. F inverse of x. The name of the function is f inverse. The variable is x. F to the minus 1 of x. Now, f to the minus 1 of x is not equal to 1 over f of x. They are not the same thing. F to the minus 1 is just notation. It's just notation. And as a matter of fact, if I pull my calculator, and if you have a scientific calculator, you notice above SIN, this is the sinusoidal function, so it's a trigonometric function, you see SIN to the minus 1. That says it is the inverse of the sine function. Cosine, COS, COS to the minus 1. It's the inverse of the cosine function. TAN to the minus 1, that's the inverse of the tangent function. Now you notice good old x squared and square root. There's x squared, and what's above it? Square root. These two guys are inverses of each other. So if you have particular functions, and you see a function above it that says these guys are inverses of each other. Here's log and 10 to the x. These two things we're going to be looking at shortly. These two guys are inverses of each other. And ln and e to the x, these two guys are inverses of each other. Well, and it's above the key. And you say, well, x to the minus 1, well, you notice what's above the key is the word matrix. So it's kind of like, it's not an inverse that's above it. When these scientific calculators first came out, it did not have a second key. It had an INV key. And guess what INV stood for? Inverse. Because it didn't do all of this stuff that it does now. It was just pretty basic. So there was an INV key, and that INV instead of the second key that picked up what was above the key, and above the key was the inverse of that function, the undo button of that function. So f to the minus 1 is just notation. If I wanted to look at what is 1 over f of x, I have to take f of x in its entirety, the whole thing to the minus 1 power. When I do that, that's 1 over that whole thing to the 1 power. That's what 1 over f of x is. So when you look at it attached to the letter and there's something in between the letter and the variable, that's marking inverse. It's like we said, sine of x. If I look at the sine of x, trigonometric function, his inverse is sin minus 1 of x. Notice the minus 1 is between sin and x. So that says I'm dealing with the inverse function. I'm not dealing with a 1 over thing. So as I said, the notation is somewhat funky.